Here we have a SAT math problem. Okay, let's go to the question. In the figure above, point E is on diagonal BD and DE equals to 3 times BE. If the area of the shaded region is 18, what is the area of rectangle ABCD? Okay, here we have a rectangle ABCD and this BD represents the diagonal of the rectangle. And we have the area for the shaded region over here, that is 18. And we have to get the area of this rectangle ABCD over here. Okay, now my idea is to get the area of this right triangle DBC over here. Once I get the area of this triangle, the same area will have for this triangle DAB. Because in a rectangle, the diagonal will divide the rectangle into two congruent triangles. So whatever area we are getting for this triangle DBC, the same area will have for the triangle DAB. Then we can add the areas of two triangles to get the area of rectangle. Okay, now to get the area of this triangle DBC, what we have to do is we have to get the area for this particular triangle DEC over here. Because already we know the area of this shaded region. Once I get the area of this triangle DEC, we can add this area and the area of the shaded region 18 to get the area of this triangle DBC. Okay, for that, what we can do is we can consider this particular piece of information. That is DE equals to 3 times BE. Okay, now let me divide both sides of this equation by BE. Let me do the same thing on the left side as well. When I do so, this BE will cancel out and I'm getting DE over BE equals to 3. Here, this 3 can be written as a fraction by taking denominator 1. Now we can write both these fractions as ratios. That is DE to BE equals to 3 to 1. Okay, now let me consider the two triangles in the given figure. That is a triangle BEC over here and triangle DEC over here. And also let me assume this BE as a base for this triangle BEC and this DE as the base for this triangle DEC. Okay, these two triangles have their bases on the same line segment DB and also they have the common vertex C opposite to their bases. Then in whatever ratio we have the bases DE and BE, in the same ratio we'll have the area of this triangle and area of this triangle. Already we have the ratio of their bases DE and BE, that is 3 to 1. In the same ratio we'll have the area of this triangle DEC and the area of this triangle BEC. Okay, now let me write the stuff over here. Area of triangle DEC to area of triangle BEC equals to the same ratio, the ratio in which we have their bases DE and BE, that is 3 to 1. Okay, here from the terms of the ratio over here, we'll be able to get the area of this triangle and area of this triangle. For that, we have to multiply the terms of the ratio by the same non-zero number, say x. So that is the area of triangle DEC equals to, we have to multiply the first term of the ratio by the non-zero number x, that is 3x. Now let's write the area of triangle BEC. For that, we have to multiply the second term, which is corresponding to the area of triangle BEC. So it has to be multiplied by the same non-zero number x. 1 times x is x. Okay, here I got the area of triangle DEC, that is 3x, and I got the area of this triangle BEC, that is x. But already we know the area of this triangle BEC, that is shaded region, that is 18. It's given in the question. So the value of this x equals to 18. Now what we can do is that we can plug in this 18 for x over here. Then I'm getting 3 times 18 equals to 3 times 18 is 54. Okay, here I got the area of this triangle DEC, that is 54. Already we have the area of this shaded region, that is triangle BEC, that is 18. Okay, when I add them, I'm getting the area of this triangle DBC over here. So 54 positive 18 equals to, let me add them, I'm getting 72. So the area of this triangle DBC is 72. And then what is the area of this triangle DAB? So for this triangle also we'll have the same area 72 because as we have discussed already, the diagonal of the rectangle will divide the rectangle into two congruent triangles. So the area of this triangle, the area of this triangle must be equal. So now to get the area of rectangle, what we have to do is we have to add the areas of two triangles, 72 and 72. When I add them, I am getting 144. Therefore, the area of the rectangle ABCD is 144 square units.